dune ecosystem. So what I'm going to talk about is remove it and they will come. And so really it is restoring the ecosystem from looking at the physical factors first. But also what I want to do is I want to thank a lot of people who are also out here. Teresa Scholars was really instrumental in this. Rhiannon was on site. Andrea Pickard from the north, who's done a lot of dune restoration. Dr. Peter Bay, on and on. This really was a collaborative project, and I was really honored to work with Peter Warner, who was instrumental in doing the mitigation and the rare plant monitoring, along with Teresa. Great fun. Oops. Okay, so this system really was of statewide significance, and I think in that case, you know, I also have to thank our managers at headquarters at state parks because they recognized that. And there was not full support within the community or within state parks for this project. A lot of people saw it as a coastal access removal. We saw it as restoration of a dune ecosystem in a natural preserve, which was extremely important. The Public Resources Code guided us. In a natural preserve, we are supposed to be restoring habitat for rare species and restoring natural processes. And so what we did, the main factor that I talked about, remove it and they will come, we removed a road, the culvert crossings that were part of that, and the road was part of an old log hauling system that went from the 10-mile river to the town of Fort Bragg. And we also removed non-native species. The project goals, again, I just said that, but was for basically we had 3 federally listed species and numerous other rare species that Peter is going to talk about. But the federally listed, snowy plover, the Howell spineflower, and the Menzies wallflower. The project location, again, as I said, I'm not sure if I said, but if I didn't, it's north of Fort Bragg in Mendocino County. The dune system, it consists of 3 main lobes divided by 2 stream channels. Really important fen ecosystem in the lower wetland area. So again, a really significant wetland dune complex. The heavy equipment was used to put in the road, which was originally a railroad trestle, and so heavy equipment was used to pull it out. We worked with a great contractor, and we also worked with the tribes. This was a really important area for the tribes. The Mendocino Reservation was also there, a sad story in the past, but not only by law did we have to work with the tribes, but we felt it was really important, and they really felt a spiritual connection to the area, so it was wonderful to have them on site as all the work was happening. And as you can see, okay, 2013, the road went through there, obviously bisected a moving dune system. The middle picture shows when the wave action came up, it started at the lower end, at the southern end, eroding away the road surface. But it wasn't a clean erosion, of course, and you ended up with this barrier. 2018, you start to see the natural processes that really started to return. You have the natural dune formation. Oops. Meow. Okay. And again, 2018. You can see the natural undulating dune, which is formed by wind action, the sand source from the beach. You have the longitudinal foredune ridges and dune hollows, and the native vegetation coming back. And I'm going to turn it over to Peter.
Thank you, Renee. I do want to repeat something I think Renee alluded to, is not only the planning process within state parks provided us motivation for this project, but the regulatory apparatus and the legal apparatus and the protection for rare plants and habitats for sensitive species, plants, animals, and otherwise provided us a great deal of motivation to essentially do the right thing on the ground, not only through the project itself, but through the development of mitigation measures, because, as we're going to see in a moment, we actually did, even though we were doing an ecologically beneficial project, that we were likely to have impacts on sensitive species during this process. So just a quick summary of the vascular plant taxa, both within McCarricker State Park, about 500 species total. About 350 to 400 of those actually grow in the preserve, which is at the northern end of McCarricker State Park along the coast. And of those, 21 species within the park are ranked 1B or 2 species, and 16 of those are in the preserve. And within our project area, as well as the sites that were selected for mitigation, 12 rank 1B or 2 species. This table is just a summary of those plant species. All those highlighted in the colored bars are within our project area and mitigation sites. And in particular, the ones in the darker bars, Abronia, Coryzanthe, Erissimum, and Enothera, were selected out for addressing specific project-related impacts and mitigation measures. And I can return to this if any of you have questions later on as well. So what were some of those anticipated projects that we had to address through the CEQA process? The potential for destruction of native vegetation, in particular, at the creek crossings. See a culvert down there? I'm not going to use the pointer. I think you'll be able to see most of this. But also the potential for the introduction or further dispersal of non-native plants in the dune system. And 2 of those are visible at the top. You can see some rather sparse stand of European beach grass, and in the very lower corner, some Armenian or Himalayan blackberry. So the road corridor itself, which was to be removed, the asphalt, was not coincidentally habitat for one of our rare plant species, Howell spineflower, a federally endangered species. But it is an artificially maintained habitat that benefits that species among a number of non-native species. And also the loss of, not only loss of habitat, but just the loss of individual rare plants and propagules. So this diagram, I don't know how well you can see it. Maybe this would have been a good idea. I have the pointer, but the Hall Road is pretty much, if you follow that arc that bisects those red patches, the project, the actual eventual project area where the road was removed starts at the very apex of that curve at the north, at the top end of the map. And the corridor of Howell spineflower is shown mostly in red from 2011 mapping program. And then the inset is about another half mile south, close to Inglenook Creek, about a mile south of that curve. So those red blotches mark pre-existing stands of Howell spineflower. And Howell spineflower became pretty much the keystone species upon which we based a lot of our mitigation measures, just because it was likely to have, more impacts. So, working in conjunction with a number of others that Renee had mentioned, I developed 3 general mitigation strategies. The first of which really isn't mitigation. It's really just during the project and post-project, following along that road corridor to see what kind of recovery or rehabilitation we achieved in terms of restoring native plant communities and dune processes. But more deliberately, we're kind of hedging our bets here. We kind of took a chance that we might be able to introduce, in particular, Howell spineflower, but also to augment pre-existing populations of Menzies wallflower, our 2 federally listed plants in the project area, into essentially novel habitats. So kind of going out on a limb and saying, well, why doesn't this plant grow here? It seems like good habitat. Well, let's try it. So that was one deliberate mitigation strategy that we pursued. The second was based on a 2005 pilot study that I worked with funding from the U.S. Fish and Wildlife Service to remove competing vegetation in areas that also were essentially good habitat for Howell spineflower in particular. We had very favorable results from that 2005 pilot study in terms of increasing populations of Howell spineflower. So we went with that for enhancement. It turned out that the funding for the enhancement part of the mitigation was accrued over time, so the plots actually weren't all established at the time of the project. In fact, not all of those plots have yet been followed through in terms of removal of ice plant. But as we'll see, that was of little matter. So what were the actual project impacts? Actually quite minimal. First of all, the contractor did a great job avoiding impacts. We had monitors on site the entire time during the project. Very minimal, as you can see, 0.04 hectare at stream crossings in terms of riparian vegetation removal. There has been sporadic establishment of particular things like yellow sour clover and sheep sorrel along the former road corridor. And then really minimal losses about the 4 designated rare plants that we knew we would probably have effect through the project. European beach grass. This is pretty much what it looked like 4 or 5 years ago, immediately along the Hall Road looking inland. This map, I don't know how well you can see it. Interestingly, most of the areas where the European beach grass has been removed is shown in kind of a lavender shade. Also primary habitat for Howell spineflower along the road corridor. European beach grass, actually this map is a relatively recent iteration of a long-term mapping process. A good portion of that beachfront area at one time was covered with beach grass, and about 90% of it is gone. And incidentally, all the removals conducted in the last several years have been completely done manually. So our mitigation objectives, just very briefly, for the federally listed species, which we knew we would probably have a direct impact on through the removal of the road, we mitigated at 8-to-1 habitat lost to habitat restored. Eight for habitat restored and 1 for every acre or spatial area that we actually affected during the project. And for pink sand verbena and wolf-eating primrose, we mitigated at a 4-to-1 ratio. Just a brief summary, some of our mitigation actions. This was conducted over several years, involved getting an incidental take permit for collection of propagules for both Howell spineflower and Menzies wallflower, establishment of our plots of those 3 different types I mentioned earlier, the ongoing mapping of the invasive species as well as the rare plants, and then the implementation of how we were actually going to try to mitigate, which included, after seed collection, seeding our compensation plots, and then ongoing beach grass removal, and then with the augmented funding, the removal of ice plant as well as litter on some of our enhancement plots. Just a kind of a quick overview. This map pretty much spans the 3+ miles of the preserve waterfront. The southern part of the preserve is almost at the bottom of the map there. Those lower few green bubbles are actually plots that are in McCarricker State Park but not in the preserve. The red bubbles mark our project area plots, and the green pretty much at the top with the yellow labels are our compensation plots, so seed introductions, and the white numbered plots towards the bottom are ice plant removal enhancement plots. And this is just a little bit of the work. Essentially the introduction of both Menzies wallflower and Howell spineflower seeds to our plot areas. We had collected the seed, dispersed the seed, and then raked it in, and essentially walked all over and trampled on those nascent seed banks that we were trying to establish. This map, unfortunately, a lot of the information is obscured, but this is at the very lower end of the preserve and the very north part of McCarricker. The areas in bright green are the more recent areas of ice plant removal, and unfortunately, this map was I didn't produce this map, but what happened was the different polygons actually obscure information. So it's rather unfortunate, but you get a general idea of the kind of the connectivity between the habitat of Howell spineflower and ice plant. Pre-treatment of ice plant with organic oils, clove oil and cinnamon oil, actually not a systemic herbicide. It was an organic method of reducing biomass and reducing the eventual workload involved in removing ice plant. Here's just a close-up of the encroachment of ice plant into existing spineflower habitat. There's also a lot of hawkbit seed heads in there. Close-up of Howell spineflower again. So our results, simple bar graphs. Blue bars to the left of the project area plots. If you look at that trend for Howell spineflower, we actually have lost individual plants. It turns out it's a little bit misleading. Just outside many of these plots, we had wonderful populations of spineflower. It's just a matter of chance that some of our monitoring plots within the project area didn't pick up some of those pre-existing and still extant patches of spineflower. The center bars are our compensation plots, seed introduction. Of course, we started with 0 for Howell spineflower. There were no plants on those plots. And what we've seen over time is we actually did get a great deal of establishment. I think out of 15 plots, we still have extant subpopulations of Howell spineflower on 3 of those, or rather on 10 of those, 2/3. And then finally, the enhancement plots. We did have pre-existing populations all the way to the left on those enhancement plots. And even without a full complement of enhancement plots, we got great results in 2015, the first year. But it was a very small number of plots. We did no monitoring in 2016, and then 2 years ago, the count of individual spineflower plants on just the enhancement plots was through the roof. It was literally too much for us to accomplish, and too much for me to graph. So almost 16,000 plants on a total of 8 plots. Menzies wallflower. A little bit more mixed results, although again we've sustained pre-existing populations in the project area have increased. On the compensation plots, we started with some plants. Menzies wallflower was pre-existing on some of our compensation plots, so the seed introductions were to augment pre-existing stands of wallflower. But we've seen quite a rapid increase on those plots, and we've seen a gradual increase in terms of Menzies wallflower on the enhancement plots as well. And then just some before and after pictures to show you the effects of removal of ice plant. These were not done in true photo point protocol fashion, but these are taken from the same area before and after. And the yellow splotches are Menzies wallflower on a dune that's been largely converted from ice plant to native species. The same dune system from a different perspective, the way it looks after the road removal, after the ice plant removal. Some Howell spineflower moving into the areas that were previously covered and dominated by ice plant. And with European beach grass, this is prior to the project, and you still see the culvert on the right, and prior to beach grass removal, which ensued about a year after the culvert and road removal, and pretty much what it looks like today. Now, some of the other species that we did mitigate for, and I'm just going to quickly go through these if you can read fast, read some of my notes there. We were able to achieve all our mitigation objectives within the first 3 years of this project for all of those 4 sensitive species that we targeted for mitigation measures. Pink sand verbena, we actually had we had 37 plants based on 14 that were damaged. We were looking for a 4-to-1 mitigation. We didn't quite achieve that on our plots, but we did do a project-wide survey and came up with almost 700 plants in that project area the very first year of monitoring after road removal. Wolf-eating primrose pretty much held the population stable within the project area. And these are just some of the other annuals that were on that table I showed you earlier. Northwest Phacelia. We actually increased or affected a small increase in plant cover on especially the enhancement plots. Dartmouth Gilead, quite a large increase. We actually pretty much discovered a new subpopulation in the process of monitoring, but also affected an increase on enhancement plots, again through removal of ice plant. Round-headed Calencia, pretty much the same story where we had, these are all annuals by the way, great deal of fluctuation, natural fluctuation in population levels from year to year, but we were able to observe and measure increases in cover for a lot of these species, especially on those enhancement plots. And a perennial that has held stable on those enhancement plots over time. So just to sum up, we have achieved many of the project goals. I'll let you kind of look at those. Just to kind of, the punchline is, have we established a new population, new subpopulations of Howell spineflower? We don't really know yet. It's far too early to tell. Again, these are annuals. they're going to fluctuate a great deal. And as the habitat itself reforms itself due to the restoration of the aeolian and wind-driven dune-forming processes, will probably create kind of a shifting habitat types in the dune system. With that, I'm sure we all want to lay our heads down in the sand. We're getting tired. Questions?